Hello, beautiful people. In this video, I'm going to go through some of the questions on your classwork today. We're going to start with question number 5, which is asking you to determine the number of terms in each arithmetic series. Now, this is example 1, but it is question number 5 in your classwork for arithmetic series day 2. Now, we have the sigma, and on top we have an n. This is an unknown upper limit. Then we have k is equal to 1. And our explicit rule is 9k minus 9 is equal to 7,020. The first thing you're going to do is you're going to solve for your a sub 1. Now, the term in the first position is going to be your explicit rule for k when you put in the lower limit number. So I'm putting in 1 because that's our lower limit. So we have 9 times 1 minus 9, so we have 9 minus 9, and a sub 1 means it's 0. After you find out a sub 1, you're going to write out your formula. It's the same formula that we used for the arithmetic series. S sub n is equal to n divided by 2 times a sub 1 plus a sub n. S sub n, we know what that is, and that's going to be this value right here. This is your S sub n. So we're going to take that number, and that number is 7,020. N is unknown. That's what we're trying to solve for. A sub 1 we already found. In this case, it was 0. And here's where the tricky part happens. That is your a sub n. Now, your a sub n is going to come from this given explicit rule. But instead of using the letter, the variable that they give you, you're just going to convert that to an n. So I have a 9n. So now we're changing it to n minus 9. From here, if you need to, when you need to, you're going to combine like terms. So we have a 9 and a 0, negative 9 technically. So we have 7,020 is equal to n divided by 2. Here we have 0 minus 9, which is just negative 9. And we pause for a second. Before you do any sort of distributing, we need to get rid of that 2 from the denominator. So I'm going to multiply by 2 on both sides. Right now it's dividing by 2. I'm going to multiply by 2, making that 2 in the denominator go away. We are now left with 7,020 times 2, which we have is 14,040 is equal to n times 9n minus 9. And we're going to now distribute that n. We got 14,040 is equal to 9n squared minus 9n. And here, because we do have a quadratic, we're going to have to subtract this 14,040 both sides. We have 0 is equal to 9n squared minus 9n minus 14,040. Now I'm going to take that 14,040 and I'm going to divide by 9 and see if that gives me a good number, and it does. That means that I can take my leading term of 9, and just like I would in IM1 in algebra class, divide all of my terms by that number. Now you can take out the GCF and keep 9, knowing that that's not going to be part of your answer. But typically here you just divide if you can. So this ends up being 9 squared minus n minus 1,560. Now we're going to guess and check two numbers that multiply to 1,560 and add up to a negative 1. So this is guessing and checking. So I'm going to set up my 2 parentheses and an n, and again we want this. So I'm going to divide this and see 1560 divided by 20. That doesn't give us, and I know it has to be numbers that are close to each other, so that doesn't work. I'm doing 20, I'm doing 40, and 40 and 39 do end up working. Now, how did we guess these numbers? It's literally guessing and checking. So I guessed 20, it didn't work. I guessed a 40, and it did work. So that means I want a negative, so I'm going to do a negative 40 and a positive 39. This is not the rainbow method, so we are not dividing. Here I'm going to set each of these factors equal to 0 and solve. So 0 is equal to n minus 40. N plus 39 is equal to 0. Add 40 here. Subtract 39 there. So n is 40. Subtracting 39. And remember, if it is not a whole number, if it is negative, we can't have that as part of our solution. So for us, how many terms did we add together? We added 40 terms. Let's go ahead and move on to a second example, which is going to be question number 6 on your classwork. And question number 6, I'll just label it question number 6, even though this is our second example on the video. So again, we have our sigma, we have our n, our unknown, we have k is equal to 1. Now it doesn't always have to be k, it just happened. 10k minus 4 is equal to 1,140. So then, just like we did before, first thing you're going to do is you're going to solve for a sub 1. That means you're going to take your equation, the one that's given, your explicit rule. You're going to copy that down. And you're going to open up that variable, that k, and input your lower limit number. Now, our lower limit is 1. So we end up having 10 times 1 is 10 minus 4. We end up getting 6. So a sub 1 is 6. After we find a sub 1, we then take our equation, s sub n is equal to n divided by 2 times a sub 1 plus a sub n. We do know what s sub n is. S sub n is 1,140. N is still unknown. A sub 1 we said was 6. And here's where you're going to take the given explicit rule, this one right here, you're going to bring it down, you're going to replace a sub n, but remember, you're not keeping that k or whatever variable they give you. You are changing that to an n. So we have 10 n minus 4 from the given explicit rule on top. Combine like terms. So we get 1,140 is equal to n divided by 2. We got 6 minus 4, which is 2, so 10n. 6 minus 4 is a positive 2. Remember at this step, you don't want to distribute this fraction. Get rid of the fraction. And we do that by multiplying both sides by 2. This ends up eliminating, dividing out, removing that 2 in the denominator. And we have this 1,140 times 2, which is 2,280, is equal to n times 10n plus 2. This is where you're going to distribute the n, so 2,280 is equal to 10n squared plus 2n. And again, we notice this is a quadratic, so we're going to subtract 2,280 both sides. Now, I am already foreseeing a little bit of a problem because unlike the other examples we did in our notes and example 1, which was question number 5, I can't just divide everything by 10 and make it into a trinomial with the leading coefficient of 1. So instead, I am going to see what number I can divide everything by, and that number happens to be 2, which ends up giving me a leading coefficient of 5, and that means we have to use rainbow method. Now recall, rainbow method is when you take the leading term and you're going to multiply it by your constant, so we're going to be multiplying by 5, and we get n squared plus n minus 1,140 times 5 is 5,700. Now we get to guess and check. Yes, these are bigger numbers. That is normal. And now we guess and check two numbers that multiply to a negative 5,700, but add up to a positive. So let me see here, again, guessing and checking. So we're going to guess. So I'm typing in 5700 into my calculator. And I'm going to be guessing random numbers. So like if I divide that by 57, 57 and 100 doesn't give me a positive 1. So that doesn't work. What if I do a 40? I think 40 worked last time. Nope, that didn't work as well. I did 20 on the other example. I'm just doing 30. So let's see, 30. Does that work? No, that doesn't work. And we're going to sit here for a little bit and play around with this. 5700 divided by, I'm thinking here, you guys. Again, hopefully you're guessing and checking with me. Oh, and I got it. I got 75. So I need a positive 1, so that means positive 76 goes here, negative 75 goes here. How did I get that number? I just guessed and checked. Lucky. Okay, now remember, you did multiply by a 5, so that means we need to divide by 5. This is the number one mistake on rainbow method, is you forget to divide after you get your factors, so make sure. Next, we have to, like I said, divide. 75 divided by 5. That one does simplify to 15. Here, 76 divided by 5. That doesn't simplify. And that stays at 76. So we got 5n plus 76. That stays. Now, our goal is to solve for n. So we still are using the zero product property, which means setting each factor equal to 0 and solving for n. So 0 is equal to 5n plus 76. 0 is equal to n minus 15. We're going to add 15 to both sides. So n is 15. Here we're going to subtract 76 and then divide by n. And immediately I am noticing that this one will not work. I'm noticing that it's negative, which is immediately a no-no. But then I'm also noticing that we end up not with a whole number, so a double no. Remember, your n values have to be positive and your n values have to be whole numbers. So this one doesn't work. So our n value for question number 6 is 15. Let's do one more. Question number 7. Again, we will have the unknown upper limit. Then we have the, I'm noticing all of these examples are using k. It's not always k. Just, I hope you see that. So 16 minus 10k is equal to a negative 390. Again, step number 1, we're going to solve for a sub 1. That means you're going to take the equation. I keep saying equation. It's the explicit rule. Take the explicit rule. You're going to open up for k or whatever letter they give you, and you're going to put in the lower limit number of 1. So this, you're just copying and pasting. Then you're taking that 1 and you're going to put in that 1 here. So we got 16 minus 10. We get 6. So a sub 1 is 6. Next, you're going to write out your equation. S sub n is equal to n divided by 2 times a sub 1 plus a sub n. S sub n is given to you. This is this number right here. You're going to take that number, you're going to bring it down, and you're going to replace S sub n with that. We got negative 390 is equal to n divided by 2 times a sub 1 we said was 6 plus, now this is where you take the equation, I keep saying equation, the explicit rule, bring it down, and you're going to replace a sub n with that. Now remember, you're not using K or M or whatever letter they give you. You're changing that letter to an N. That's all you're doing with it. And then you're going to combine like terms. So we got 6 plus 16. And that will give us 22, I think. Yeah. So we got 22 minus 10n. And again, in this step, you're going to be multiplying by 2. Oops. Twos go away. We got negative 390 times 2, which gives us a negative 780. 22 minus 10n. Distribute that n. Negative 780 is equal to 22n minus 10n squared. Now again, I am realizing this is going to be the same hiccup that happened last time, where we won't have a leading coefficient that is 1, and that's okay. I'm going to add 780 to both sides, and I'm going to rearrange this in standard form. So we got 0 is equal to negative 10n squared plus a 22n plus 780. We're going to find a number that we can divide just to make things simpler. You can just pull out a GCF, or you can just divide everything since we are solving an equation. I'm going to divide everything by a negative 2. The reason I'm choosing to do a negative, not a positive 2, is because I need this leading coefficient to be positive. So we got a positive, negative 2 here as well. Every single term gets a negative 2 or nothing gets a negative 2. So we have to make sure that we also divide this 0. So we get 0 is equal to a positive 5n squared, a negative 11n, and a negative 780 divided by 2 is 390. Once again, we are left doing a rainbow method because our leading coefficient is not 1. So we're going to take this 5, we're going to multiply by this negative 390. So 5 times 390, n squared minus 11n, what do we have? Minus 1,950. And now we're doing our guess and check. And we're guessing and checking. So 1950 divided by, I don't know, 50? Maybe? The only reason I did 50 because I saw 50. So 39 and 50. 50 minus 39. Nice. I did get lucky here again. Luck is on my side in this video. So we have, what did I say we had? 50. We have a minus 50 because we want this to be negative. Adding up to a negative, multiplying to a negative. And then that was 39. Positive 39. Again, these are not your factors. These are temporary factors. Since we multiplied by 5, we have to divide by 5. So 0 is equal to n minus 10. And 39 is not divisible by 5, so 5n plus 39. At this point, you should get an uncomfortable feeling about 5n plus 39. You should know that if we were to solve this, this won't work, because it will not give you a whole number. But let's keep going. Oops, this should be a minus 10, not a plus 10. My brain's already thinking ahead of my hands writing. And this one again, I'll give that time to dry. So subtract 39 on this, and then divide by 5. Is this necessary? No. If you are already comfortable in saying this will not be an answer, I'm okay if you skip this step and then just eliminate that and just say, hey, this is not going to be your answer. That's fine. What I'm more concerned is about the actual answer. This is minus, so we're going to add 10. I don't want you skipping steps when you're not ready for skipping steps. This one, again, not a whole number, not positive. So the only answer is 10. All right, beautiful people. Hopefully these 3 examples did help you. I will see you in class. Bye!